This chapter, you do have to do proofs now in chapter 4. So, these 4 we did in the assignment yesterday, and I told you to just put the reason that made them congruent. So, I'm going to do the proofs for you. We're going to spend, you're not going to have to do proofs yet. Next week we'll start doing the proofs, but I want to do a few each day so you get the hang of it. These, almost everything is given to you on these. So, for number 21, if you had to do a proof, which again, eventually you'll have to, we're just going to do the 2-column proofs. So, when you're doing one, we're doing this one. This one has a bunch of given stuff here. So, you can put all the givens right away. You could scatter them throughout if you wanted to. I usually put them in right away. So, it tells us NP is congruent to QN, is congruent to RS, congruent to TR, and PQ is congruent to ST. The reason why I can put that down is they're both given. Now this one is as easy as a proof gets. We're trying to prove triangle NPQ is congruent to RST. There's nothing we got to put down because everything was given to us. We already have these two sides, they're all 4 equal, and these two sides. So, we have the stuff you can put down to prove then. Triangle NPQ is congruent to triangle RST. And the reason why I can say that, what did he put yesterday? Side, side, side. So this is as easy of a proof there is. Everything's given to you. Now the next one, not everything is given to you. Number 22, it is given that AB and CD are congruent, and that AB is parallel to CD. So, this is what you're going to want to do, or you don't have to, but this is how I do it. I keep track of everything I know, because you're going to have to find either SSS or SAS. Today they're adding in ASA and AAS. So right now, I know one thing. I know a side is congruent. That's all I've got in a proof. Now, just looking at this picture, what do you know is true?
It wasn't about that, but today, can you, then on like our answers, can we get multiple
Yes.
different things?
Yep. So, what do you know is true just by looking at the picture?
That
Parallel lines.
parallel A, B, and C.
A, B, B, C are parallel.
Yeah, that's given to us though.
Oh, yeah.
But just by looking at the picture, this is something you got to spot.
Exterior, wait, no, interior.
Well, forget about that. Yeah, that is true, but what? Well, they will be, but what is true just by looking at the picture? It's a shared line, right? I know that this line equals itself. AC equals AC because it's a shared line. AC is congruent to AC. If you forget what the reason is, you just can put shared side, but it's reflexive. Look in the mirror, you see yourself. So, right now I've got 2 things in there, but I need one more thing. Remember, you need 3 things? So, what you were saying earlier is since these lines are parallel, I know that angle 1 and angle 2 are congruent, right?
Yeah.
Angle 1 is congruent to angle 2, and the reason why?
Because the parallel.
What kind of angles are they?
Alternate interior.
Alternate interior angles are congruent. And there I've got my 3 things. So once you have your 3 things, you put your proof statement in last. And the reason why they're congruent is SAS. Okay? The next one down here, not everything is given to you. So I start off with the givens. PQ bisects angle SPT, that's given. And they give us that two sides are equal. So far in the proof, I only have one thing. I have a set of sides. Now just looking at the picture, what do you know is true just by looking at it? Right there, that's a shared side, so PQ equals PQ.
So that'd be reflective.
Yep. Reflexive. And there I've got my second thing. Now even though it's drawn on the picture, it's not in my proof yet. See here they drew in that these two are equal. It's got one arc and one arc. Sometimes people get confused because they say, well, this is a smaller arc than that, so they're not equal. The only reason they do that is because otherwise it would look like one big line. So we can see here they're equal, but it's not in the proof yet. So we've got to put in there that angle SPQ is congruent to angle TPQ. But we got to put a reason why. Why do you know that they're equal to each other?
Because that's
What does it mean when it's bisected?
split in half.
Cut in half, right? Two equal pieces? So all you got to do is, since they told us it was a bisected, that's just the definition of a bisector. Because a bisector means cut into two equal pieces. So there I got my third thing, the angles. So once you have all three things in your proof, you can put your proof, triangle SPQ congruent to triangle TPQ because of SAS. Alright?
Yeah.
So on this one, you'd have to put these two givens in there. And that would be two of the things. You'd have to put one more thing in there. The vertical angles are congruent, right? So you'd put in, because they're looking for PQT, this one, and RST, so they put these extra lines in here. So you would put in there, this angle equals that, because vertical angles are congruent, and then you would put your proof because of side angle side. So it would be PT congruent to RT given, Q2 QT congruent to ST given, and then I'd have to put in that angle PTQ. This angle is congruent to STR because vertical angles are congruent. And there I've got two sides at an angle, so I can put my proof in. PQT is congruent to triangle RST because of side angle side. So they're not real difficult proofs. The more you see them, the easier they are to get used to. So, today's stuff, it's just like yesterday's, yeah. You're going to still have pictures of triangles. So again, we've already learned you can use SSS, SAS. Today they're adding two more. ASA and AAS, which you could write SAA. It doesn't matter which order you write it in. So ASA means
Angle side.
angle side angle,
Angle side.
and then angle angle side. Now remember I showed you that ASS doesn't work. That's not a reason that you can use. And I'll show you the reason why.
Because it spells a bad word.
Because it spells a bad word is the main reason. But you could have a triangle like this.
Oh.
I'll try and make them the same. You could have two triangles where,
Oh, upside down.
Would ASS work? Like for, that it won't work?
here's an example of an angle side side and another angle side side. These two angles are equal. This side is the same length and this side is the same length. It's just it's been flipped this way now. So obviously this is not the same as that. So this is the example why angle side side doesn't work. It could work, it just doesn't always work. Does that make sense?
Yes.
Okay. So again, today's assignment, you'll just have two triangles or one picture with the triangles together. You gotta give the reason. Here's an example of angle side angle. Angle side angle. You guys getting used to reading those now, how the letters would spell out? So remember, you can't start here and go this way because you'd be jumping a side, an angle, and another side to get to there. So you gotta start here and go that way, or here and go that way. Angle side angle. This one, we've got an angle, angle, side. Or you could have started at the side and went side, angle, angle. Either way you write it, they're the same thing, it's just written backwards. So in this picture, again, you know it's got a shared side right there. Do you know anything else that's true?
Oh, reflection.
There's an angle.
Oh, we already did it.
This nine, these are equal.
It's no.
So this is a no. You just don't know enough. We know that these two angles are equal and we know that side, but remember you need to know three things. So if you don't know three, it's just no. Here, it's got a shared side. So looking at this triangle, angle side angle, angle side angle, ASA. Some of these triangles now, when we get into it, there'll be more than one thing that works. But you don't need to put all the reasons, you just need to put one. So on this one, we've got a shared side right there. And can you guys see that this has the parallel line triangle on it?
Yes.
Okay. So that doesn't mean they're equal, it just means that alternate interior angles will be equal. So this angle will equal that one. So here's an example of a,
Angle, side angle,
no,
side angle, side.
no,
Angle,
Yeah,
angle,
so-
side.
angle, angle, side. If you start here, it goes angle, angle, side. Angle, angle, side. Or if you go backwards, it would go side, angle, angle, side, angle, angle. So remember, you can skip a side if the angles are back to back like that. But you can't skip all the way from here over to there because you're skipping a side and an angle. Oh, these we don't have to do. Okay, so this one, it tells us in the given that R is the midpoint of QS. So what do you know is true from this information? This side equals that, because midpoint means it cuts it in half. And then it also has it marked in there that these two are equal, and it has it marked that they're 90s. So what would make these two congruent? Yep. Angle, side, angle, angle, side, angle. Got it down? So now today's assignment, you'll have 4 choices to choose from.
But all we have to do is write one of those for each.
Yep. Or if it's a no. So just like yesterday. Yep.